is the Big Bang Theory.
Big Bang.
It's the Big Bang.
The Big Bang.
Big Bang.
Big Bang.
Starting from the Big Bang, this universe holds countless mysteries, and one of them is dark matter. Just like honest politicians, we know they exist but don't have proof. So what is the Big Bang, or what is dark matter anyway? Well, let us rewind the time a little bit. It all started approximately 13.8 billion years ago. In a vast nothingness, there was an infinitely hot and dense point, which we call singularity. This point exploded in an unimaginable force, which resulted in the creation of matter and eventually the universe we know today. Or, in simple and crude words, the Big Bang is the explosion that created the universe. Surprisingly, this theory was first proposed by a Roman Catholic priest and physicist, Georges Lemaître, in 1927. Just kidding, he was an excellent physicist. But where is the evidence? Before the 1920s, it was thought that the universe was static, or the universe was at the same size. However, this notion was broken by astronomer Edwin Hubble in 1924. He used a technique pioneered by Henrietta Leavitt to measure the distance celestial bodies from the Earth. He used spectroscopic redshift data to measure the speed these objects were traveling, then graph their distance from Earth against their speed. He found the speed at which astronomical objects move apart is proportional to their distance from each other. Or, farther the two galaxies are, faster they will move apart. It is also known as Hubble's law. Based on this law as evidence, Lemaître was able to propose the Big Bang Theory. But the major breakthrough came when cosmic microwave background radiation was discovered. As the Big Bang Theory was established, a theoretical framework was ready. Now scientists were trying to find direct evidence of it. But this evidence came in 1964 when two radio astronomers, Arno Penzias and Robert Wilson, accidentally captured signals as background noise via the antenna they built to research how radio signals could be reflected off orbiting satellites. So what is this CMBR? CMBR, or cosmic microwave background radiation, is essentially the first light or the first radiation created shortly after the Big Bang. Or we can say it is the remnant of the first light which is present in the universe. Sounds fascinating, right? This is the charm of science. With CMB radiation, physicists were able to see the distance past, the closest thing we came into contact with the Big Bang. Do you know there was another thing that played an important role in the Big Bang, the creation of the universe? Yes, dark matter and dark energy. But we will talk only about dark matter. So, what is dark matter? Let's hear another story. So the time is 1933. A Swiss-American astronomer, Fritz Zwicky, was observing the Coma galaxy cluster. While observing, suddenly, he noticed something strange. Something so strange that was defying the laws of physics. He saw that the speed of galaxies were moving in the cluster was too fast, that logically they should have been thrown into space. Yet they were bound by the gravitational pull of the cluster. Fast forward to the 1970s, astronomer Vera Rubin also saw a similar problem with spiral galaxies. The stars on the edge of the galaxy should be thrown to space, but they are bound by gravity. Where is the problem here? All simple, right? Gravity is holding all together as it is meant to be. But, according to the general theory of relativity and calculations, the mass of the galaxies or the stars is not enough to generate that much gravity. So there must be something influencing the mass of the galaxies, a missing matter, which Fritz later named it dark matter. So dark matter is a strange thing. It is a hypothetical form of matter that does not interact with light or the electromagnetic field, but is inferred by gravitational effects that cannot be explained by general relativity unless more matter is present than what is visible. Or, in simple words, it is a hypothetical form of matter that has a solid relation only to gravity. Do you know what the funny thing is? We know dark matter exists, but we don't have evidence. The dark matter makes up approximately 85% of the total mass in the universe, and the rest is ordinary mass. The total mass content in the universe is approximately 31.8%, and the rest is dark energy. Now, we have a massive question. Why did scientists think it was missing matter, not something else? I mean, there might be some other reasons, but particularly, why dark matter? While some alternative theories propose modifications to gravity at large scales, such as different laws governing galaxies or weakening of gravity over vast distances, These ideas lack the robust evidence needed for widespread acceptance. Additionally, they fall short of explaining all the observed phenomena. In contrast, the theory of dark matter offers a more comprehensive explanation. Supported by strong indirect evidence, it suggests the existence of invisible matter that exerts a gravitational influence, shaping galactic structures and explaining their otherwise unexpected behavior. According to Fritz's observation, the visible mass of the galaxy contributes only 1% of the gravitational potential, so there must be mass that is missing, and it is not visible. Still, there should be other reasons, right? On the other hand, a phenomenon called gravitational lensing says something else. Gravitational lensing is a phenomenon in astrophysics where light from a background source is deflected by the gravitational field of a massive object, such as a galaxy or a galaxy cluster, as it travels towards an observer. Or, massive heavy objects create super high gravity, thus bends the space-time and making it like a giant lens. It's a complicated stuff. According to experts, the degree of gravitational lensing is directly proportional to the mass of the lensing object. So how is this the evidence of dark matter? Thanks to the theory of relativity in Newton, we actually know how gravitational lensing happens. So according to data, we can actually simulate this in a computer. So when scientists tried to simulate the gravitational lensing, they found the visible mass of the galaxy, or that object which is causing this phenomenon. Not enough. To achieve the gravitational lensing, it needs 9 times more mass, which is visible, and this missing mass must be dark matter. We are still trying to find direct evidence. Scientists speculate that dark matter might be some subatomic, non-baryonic, electromagnetic neutral particle but we lack any evidence to support it. There is much confusing stuff in the universe. Have you heard of nuclear pasta born in a neutron star? To know more, click the video. And don't forget to subscribe for more such videos. That's it for today. See you in another video.